Welcome to Unit 3, Lesson 4, Video 1 for Chemistry 1. So in this video, we're going to begin talking about nuclear decay. And nuclear decay is a process by which an unstable atom loses energy by emitting radiation to become more stable. So atoms that are unstable are usually those that have really a lot of protons and neutrons in the nucleus. So any atom with an atomic number above 82 is technically considered radioactive because they have so many protons and neutrons together that it makes the nucleus unstable. But we can also have different combinations of protons and neutrons. So if we have a lot of neutrons compared to very few protons, it can make an atom unstable. But we're really not too concerned about what makes an atom unstable, but the process in which it becomes more stable. So it emits radiation, and radiation is just energy emitted by an atom in the form of waves or particles. So the sun emits radiation. We have ultraviolet radiation, which are waves that come from the sun 93 million miles through space, and if they hit your skin, they can cause a sunburn. So that energy is so intense that it causes your skin to burn. But we also have particles that can be released from substances. And because of this, we have different types of decay that can occur based on whether or not we have waves and or particles. And we harness some of this energy from radiation in nuclear reactors. We use that energy as a weapon, so nuclear weapons. And even you have a little bit of radioactive material in your smoke detector at home. And it is powered and it detects smoke particles based on creating an electrical circuit. And we'll talk about that a little bit. So we actually have three different types of radiation: alpha, beta, and gamma. And they're just named after Greek letters. So alpha emission or alpha decay is the emission of an alpha particle. So this one is a particle that is emitted from the nucleus, and it has a weird looking symbol. Alpha looks like that, and we're going to put a 4 and a 2 there. Now these are in the same place as our mass number and our atomic number. So this alpha particle has a mass number of 4 and an atomic number of 2, which means that it has 2 protons plus 2 neutrons. So an alpha particle really is a helium particle. And this spontaneously comes out of an unstable nucleus. And usually they're really big nuclei. They have lots of particles in it. And all of those particles together are unstable. So it spits this out and it becomes something new. So whenever this is emitted, it decreases A by 4 and Z by 2. So we decrease the mass number and the atomic number. Now, alpha radiation. The particle is pretty big compared to other forms. So it's stopped just by the air itself. But if you want to protect yourself a little bit more, it's stopped by skin. So your skin stops alpha decay as long as it's not an open wound. It can be stopped by a piece of paper. and clothing. The only way that this is a problem and can be deadly is if it is injected into somebody. It can be inhaled into your lungs or ingested. So it could be injected into a wound. So we'll also put open wounds. So if it somehow gets into your body, then it's a problem. And there was a couple spy cases where spies were injected or ingested with polonium, which is a known alpha emitter, and it actually kills them very slowly and painfully over time. And there's not a whole lot you can do if you're poisoned by an alpha radioactive material. So it's going to be about 2 or 3 weeks depending on how big of a dose you get. And a lot of really bad things happen with that. So this is the first video. In the next video, we'll look at beta and gamma and we'll look at some problems.